So for number 30, we've got the situation, a 5 kilogram mass resting on a frictionless horizontal table, and then we've got a 10 kilogram hanging mass. Find the acceleration of each object and the tension in the cable. So first of all, drawing the forces, we of course have the force of gravity, just the mass times 9.8. And the top one here, we've got the normal force, and then of course the tension in the rope. So solving this one, we have all of these forces. Again, remember the tension force is internal. These two are going to be equal and opposite to each other. So if we solve F net equals ma, the net force in this case is just the 98 newtons acting on the bottom mass. How much mass is being accelerated by that? Well, all of it. So the mass being accelerated by this, and I'm leaving off units just for speed, is going to be 5 plus the 10 kilograms, all times the acceleration. So the acceleration then, if you solve it, 98 divided by 15, should be about 6.53 meters per second squared. Once you have that acceleration, we can answer the second part of the equation. So here's our first answer. The second part asks, what's the tension? Well, to solve that, you've actually got to look at one of the masses by themselves. In this case, I'm going to arbitrarily choose the 10 kilogram mass. So we've got the 10 kilogram mass, and we know that it's accelerating downward now at 6.53 meters per second squared. Well, if you figure this out then, what's the net force on just this 10 kilogram mass to accelerate at that rate? Well, if we do F equals ma again, we've got 10 kilograms times that acceleration. Sorry, it takes me longer to write this than it's worth, 6.53. And you'll figure out that the net force required is 65.3 newtons downward. Which means the force of gravity has to be larger than the tension by that amount. And if we solve it then, we can very quickly figure out the tension is about 32.7 newtons. Why? Because that is 65.7 newtons less than the 98.